Hello, welcome back to another video. So, joke, uh, uh, every time, why did the knight put a light on his horse so he could find his way home at night? Ha ha ha, because saddle light navigation. Ha ha ha. Okay. Hoping that you guys still love these jokes, eh? Speaking of lights, we're talking about projections. And in terms of vectors and projecting kind of one vector onto another vector, okay? It's basically rescaling and moving a vector onto another vector, and you kind of like, I think of it as almost as if like you're casting a shadow from one point to another. Now, the important part here is these two vectors need to be tail to tail. If it's head to tail or tail to head, not going to work. You're going to have to reverse one of the vectors. They need to be tail to tail. And then you'll find, I guess, you'll project at a particular angle and you'll project one onto the other. Okay. How it might look is, for example, I've got this vector u. You can see that it's kind of pointing up this way. And then we've got this what do you call it? This vector x here. So we've got vector u and vector x. And if I project u onto x, it's actually going to shorten a little bit as if we're shining a light. It kind of shortens a little bit. That's what we call our projection of u onto x. Okay. The way we do it is we draw like a right angle. We kind of project it kind of onto a right angle onto the other vector. And that's what it would be. Now, of course, so many different situations will call for so many different things. So that's why we've kind of created two different formulas that we use for this. Now, we use projections in a lot of things. Later, you'll find that we use it for, I guess, even like things like force, and you're projecting a force onto like another section or another weight onto another line. We'll see how we use those. But for the time being, let's learn the mechanics of how to actually calculate these projections. Okay. Now, you're given a geometric formula here, and I'm just going to put that on the screen. And the way that we would say something like this is we would say that this is the projection of u onto x. So it's kind of like whatever you're projecting onto, that becomes your subscript. Now it's saying the projection of u onto x, it's going to be the length or the magnitude of u. Now it's not always going to be length. If we're talking about force, it's talking about the magnitude. So we'll say magnitude times cos of your angle in between, and then multiplied by the unit vector of, I guess, whatever you're projecting onto. Okay. This is a helpful formula here. I'm going to give you the other formula as well. This is where if we want to use the dot product instead, if we're given the values for those two other vectors, it'll be very, very similar. We'll have this one here where it's u dot with the unit vector of x, and then it's going to be times the unit vector of x, or this is the one that I found is probably slightly more useful in these calculations. It's u dot x over x dot x times x. Okay. Putting it over x dot x, that just makes that x into a unit vector. Okay, so those are the formulas. Let's have a practice go here. Let's say a equals to 2i minus 3j and b equals to negative I plus 2j. Let's find the projection of a onto b first. And so the projection of a onto b is going to be a dot b over b dot b times b. And if you take a look below, if we want the projection of b onto a, so we're projecting the other way, we just kind of reverse everything. So all the b's turns to a's, all the a's turns to b's. It's just going to be b dot a over a dot a times a. So to calculate this, let's go. A dot b, if I dot a and b, it's going to be 2 times, I'll write it out. 2 times negative 1 plus negative 3 times 2 over b dot b. So it's going to be minus 1 times minus 1 plus 2 times 2, and then times the vector of b. And so this is just going to be negative 2 minus 6, that's going to be minus 8 over, what is that, positive 1, so it'd be minus 8 on 5b, or in other words, it'll be minus 8 on 5, and then it'll be, if I wanted to write it, it'll be minus I plus 2j, because that's what b is. Okay, and we can leave your answer like that. The same way if we go the other way around. Now a dot b is the same thing as b dot a, so I'm going to take a little shortcut here. I know that's going to become minus 8. Now the only thing I need to calculate here is what's a dot a. It's going to be 2 squared. I'll write it down. 2 times 2 plus minus 3 times minus 3 times a, and I can see that's going to give me minus 8 over 4 plus 9, yeah, be minus 8 on 13, and then a is going to be 2i minus 3j, okay? And that there would be your projections, nice and standard, nice, straightforward. You do not have these formulas in your reference sheet, so hold on to them, commit them to memory. Now we use these ones here if we give you the actual vectors, but again, sometimes what we'll do is we'll actually give you different things. We'll give you the angle in between. Whenever you have the angle in between, we're going to use the formula. So projection of A onto B is going to be given by the length of A times cos theta, and then all that times the unit vector of B. Okay, because we're projecting A onto B. So here, what is the length of OA? Find, okay, projection of this one. Now here, all I really need is I know the length of OA is 3, so that's going to be 3. And then it'll be cos theta, which is going to be 3 times cos 30. And then times the unit vector of B. So that means I don't know what B is, but I know to make it a unit vector, I'm going to have to divide it by its length, which in here we've said that is 6. So I'm going to divide it by 6. And let's see what we've got here. Cos 30. I should have these memorized, but I do not. Cos 30 would be H. Okay. So it would be 3 times root 3 on 2 times B on 6. And let's see what we've got here. If I calculate that, should be something like root 3 on 4B. And I've got it in terms of B, which is what I've got here. We don't know what B is, so I'm just going to leave it in terms of B. Now, if I am correct, 1, 2, root 3, yep, should be. Yep, because we know the angle in between is 30 degrees. I think I've done that correctly. That should be my answer for the projection of A onto B, okay, in terms of B. Hopefully that helps with projections. I'll see you guys in the next video. Enjoy, and I'll catch you. Bye-bye.